Hello to everyone. Myself is Dr. Vapidash B. Tangur, Assistant Professor, Sri Jagadguru Tontadariya Government First Grade College, Mundargi. So, this session is continuation of crystal structure. This is third session in this series. This lecture is program is for the BSc course. Subject is Physics, Paper 1 for 6th semester for the syllabus of Karnataka University, Dharwad. In this session, my topic of today's discussion is coordination number and coordination number for simple cubic, body centered cubic and face centered cubic structures. Learning objectives of this session is to know the concept of coordination number, to understand the crystal structure and calculations for the coordination numbers for simple cubic, body centered cubic and face centered cubic structures. Also dealing with the packing fraction for simple cubic, body centered cubic and FCC structures. And session outcomes from this session is knowledge about the solids, understanding of what do you mean by the crystals, idea about the coordination numbers for simple cubic, BCC and FCC structures, mathematical calculations of packing fractions for SC, BCC and FCC structures. Prerequisites for today's discussion is concepts about the coordination numbers in chemistry, structural analysis for SC, BCC and FCC structures, that is the previous lattices, and coordination number calculations for mathematical calculations for SSC, BCC and FCC structures. Now, what do you mean by the coordination number? Simply, coordination number is very simple. These are the number of nearest neighbors. If there is an atom, surrounding this atom, number of nearest neighbors, these are called coordination numbers. In case of simple cubic, coordination number is 6. In case of body centered cubic, coordination number is 8. In case of FCC structure, coordination number is 12. In case of diamond, this is base centered cubic, coordination number is 4. So therefore, number of nearest neighbors in case of simple cubic is 6. In case of body centered cubic is 8. In case of base centered cubic is 4. In case of face centered cubic is 12. So these are the number of nearest neighbors. These number of nearest neighboring atoms, they are nothing but the coordination number. Now we are little bit concentrating about the simple cubic structure. Example for the simple cubic structure, as we know, it is a polonium and it is closed packed structure. And here the red is the, if we take the red is reference line, so therefore two atoms along the axis, two atoms perpendicular axis, and top one atom, bottom one atom. Therefore, totally 6 nearest neighbors in case of simple cubic. Therefore, coordination number for the simple cubic lattice is 6. Now we should calculate the packing fraction, atomic packing fraction for simple cubic. Now we will define what is atomic packing fraction. Atomic packing fraction is the ratio of volume of atoms in unit cell to the volume of unit cell. So you know, it is, we are considering almost spherical. We know the volume of the sphere is 4 upon 3 pi r cube. Here radius is 0.5 into your atomic distance parameter. Therefore, atomic packing fraction for the simple cubic is 4 upon 3 pi r cube. Radius is 0.5 a divided by volume of unit cell is a cube. And if we calculate atomic packing fraction for the simple cubic is 0.522. And as the standard we know, larger is the atomic packing fraction, is the larger is the tightness of the bonding between the nearest neighbor atoms. Therefore, larger is the atomic packing fraction, is the more bonding, more stability of the crystal lattice is. And the number of unit cells per unit cells is, number of atoms per unit cell is, in case of simple cubic we have discussed in my previous class. So same thing, number of nearest neighbors is 8 atoms are arranged at the 8 corners, therefore number of corners are 8, therefore 8 into 1 by 8, number of atoms per unit cell is 1. Now we will discuss coordination number and atomic packing fraction for the body centered cubic structure. Example for the body centered cubic structure is chromium, tungsten, iron, tantalum, molybdenum. Body centered cubic, so one atom exactly at the center. Number of nearest neighbors are 8 because 8 atoms are situated at the 8 corners. Therefore, number of atoms to 8 corners. Therefore, nearest neighbors is 8. Therefore, coordination number for the body centered cubic structure is 8. Number of atoms per unit cell is 8 corners. It is 1 by 8 into 8 plus 1 body center. Therefore, it is equal to 2 atoms per unit cell in case of body center cubic structure. Atomic packing factor, we can take it. Here, again, it is a ratio of 4 upon 5, 4 upon 3 pi. R cube radius is here 0.3 A divided by 4 to the A cube. If we calculate this, atomic packing fraction for the body centered cubic structure is 0.68. Therefore, tightness of the bonding between the atoms, between the nearest neighbors is larger than the your simple cubic. It is here 0.68. As we have mentioned, larger is the atomic packing factor, is the more stable, more tightly bonded. Next, we can consider face-centered cubic structure FCC. Its coordination number, its atomic packing factor, we can consider it here. Examples belongs to FCC structure is aluminium, copper, gold, lead, nickel, platinum, and silver Ag. So here 8 atoms are situated at the 8 corners and totally 6 faces. All the atoms are situated at the center of the 6 corners. Therefore, coordination number nearest neighbors in case of face centered cubic is 12. See here, number of atoms per unit cell is 6 faces divided by pair plus 8 into 1 by 8. Therefore, number of atoms per unit cell is 3 plus 1 is equal to 4. Number of atoms per unit cell is 4 and coordination number is 12. And atomic packing factor is 4 upon 3 pi. R cube radius is 0.22 divided by 4 cube divided by A cube, and atomic packing fraction for face centered cubic structure is 0.74. So we can say very easily larger is atomic packing fraction for the FCC structure than the BCC or than the simple cubic. Therefore, FCC structures are more stable than the simple cubic and body centered cubic structures. Now we can discuss few multiple choice questions on our previous discussion. Lattice points per unit cell in case of simple cubic is A1, B2, C3, D4. Correct answer is number of lattice points per unit cell in case of simple cubic is 1. So answer is A. Lattice points per unit cell in case of FCC structure is A1, B2, C3, D4. Correct answer is 4 because we know in case of FCC structure face center there are 6 faces and plus 1 by 8 into 8 plus 2 by 6, sorry 6 by 2, 3, therefore 1 plus 3 is equal to 4. Therefore, number of atoms per unit cell is 4. Therefore, proper correct answer is D. Number of lattice points per unit cell in case of BCC structure is A1, B2, C3, D4. Therefore, correct answer is 2 in case of PCC structure. Coordination number for simple cubic lattice is A4, B5, C6, D7. Correct answer is 6. Therefore, coordination number for simple cubic is 6. Coordination number for the face-centered cubic is 12. Atomic packing fraction in BCC is 0.68, 0.73, 0.4, next 6.894. Therefore, correct answer is 0.68 is the atomic packing fraction. So this is all the discussion about the coordination number, atomic packing fraction, number of units per unit cell. So this is all discussion on our crystal structure. Thank you one and all. Thank you.